Okay, let's go ahead and get started with question number 15. It reads, what is the pH of a solution with a hydrogen ion concentration of 1 times 10 to the negative 6 molarity? Okay, because this question is asking us to solve for the pH of a solution at 1 times negative 6 molarity, you are going to use your pH equation, okay? That's going to be pH equals negative logarithm times your hydrogen ion concentration, and this is what we're looking for. So if we go back, we're going to write that pH equals the negative log of our hydrogen ion concentration, which is right here, 1 times 10 to the negative 6. Okay, and what you would plug into your calculator is this part right here, the negative log times 10 to the negative 6. Once you plug that into your calculator, you should get that your pH equals 6. So in this case, your answer is going to be C. Moving on to question number 16, it says, what is the correct name for HCl? So in naming, this semester we talked about naming acids and bases, and your rule for naming binary acids. We know this is binary because it only has 2 elements. We only have hydrogen and chlorine. So binary means 2 elements. So we know that we are naming a binary acid. Okay, and the steps for naming a binary acid are as follows. The first step is to start using your prefix hydro. Step number 2 is to use the first syllable of the second element. So this is step 1, step 2. Step 3 states that you use the suffix IC. Okay, so using those steps, we're going to go ahead and name HCl. So we're going to start off with hydro. And then it says the first syllable of the second element. In this case, chlorine is our second element, and chlorine is 2 syllables. So what we're going to use is chlor. That is our second syllable. Okay, and then the last part it asks for is just to add the suffix IC at the end. So hydrochloric, and then we know that this is a binary acid, so we have to add the word acid at the end. And your answer is going to be D, hydrochloric acid. Okay, so question number 17 reads as follows. Students performed a lab where they measured hydrogen ion concentration after pouring 4 different acids into separate beakers containing 200 milliliters of water. The table shows H plus for each of the following solutions based on the information in the table, which is the strongest acid, okay? So we know that solutions A, B, and C and D are all acids. So we're gonna look at the H plus concentration. It's asking us to find the strongest acid, okay? So what we're gonna look at is our scientific notation numbers over here. We see that all of these numbers only have 1 number after the decimal, so they all only go to the 10th place. So what we're gonna look at first is your exponents next to the 10. In this case, we're going to take a look at our number line. I'm just going to draw on really quickly. We know 0 goes in the middle, 1, 2, 3. Then we have -1, -2, -3, so on and so forth, okay? So we know that -1 numbers going this way are getting larger. Okay, so if we list our exponents, our negative numbers right here, in terms of this number line, the last number would be -10, then we would have -8, -5, and -4. Okay, and going to the right, we know that our numbers are getting bigger. So -4 is going to be our largest number, which means that it's going to be our strongest acid. Now, if there were 2 -4s, then we would have to take a look at the number that has your decimal, but in this case, there's only one -4, so we know that that is our strongest acid, so your answer should be solution D. Question number 18 says, an expandable container holds 15 liters of gas at a pressure of 2.5 atm. I'm going to go ahead and highlight 15 liters, 2.5 atm, and a temperature of 320 degrees Kelvin. The volume of this container is then increased to a new volume of 25 liters, while the temperature is held at a constant 320 K. It says, what is the new pressure in the container? Okay, so in this case, we're going to go ahead and take a look at our formula sheet. We have liters, which is volume. We also have our temperature. This is liters, this is in Kelvin. And then the last thing that we have is our pressure. Which is in atm. Okay, so let's go ahead and take a look at our formula sheet. We have a lot of equations here. Okay, we know it's not solutions or thermochemistry, so we're going to go ahead and take a look at our behavior of gases. Okay, so let's go back and look. We have volume, temperature, and pressure. Volume, temperature, and pressure. This one has pressure and volume, temperature, but we do not have our ideal gas constant or our moles. This one has initial pressure, initial volume, final pressure, final volume, initial moles, initial temperature, final moles, and final temperature. We are close, but we don't have moles in this equation, so we're also going to cross this one out. This one has initial pressure, initial volume, final pressure, and final volume. Here, it gives us our initial volume, which is 15 liters, and our final volume, which is 25 liters. It also gives us our initial temperature of 320 K, and it says that it remains constant. It's asking for the new pressure. So it gives us our initial pressure, which is 2.5. It's asking us to find our final pressure, so this one could be an option. This one has initial volume, initial temperature, and final temperature. It's not asking us to find volume or temperature, it's asking us to find pressure. So in this case, this is the equation that we're going to use right here. Initial pressure times initial volume equals final pressure times final volume. I'm going to go ahead and write that equation over here. So P1 times V1 equals P2 times V2. Okay, now let's go ahead and list out our variables. P1 equals, P2 equals, V1 equals, and V2 equals. Okay, it is asking us to solve for the new pressure of the container. So P2 is going to be our new pressure. That's what we're solving for. We're going to leave that as a question mark, and we know that our answer has to be in atm. Okay, our initial pressure, which is our P1, is going to be 2.5 atm. Our initial volume is going to be 15 liters. And then it says our new volume, which is our final volume, is going to be 25 liters. Now you're just going to take those numbers and plug them in for the variables in the equation. So we know that our P1 is 2.5 times, and it's going to be V1, which is 15, equals our P2, which is what we're solving for. So we're going to leave that as P2, times our V2, which is our final volume, which is going to be 25 liters. Okay, in order to get P by itself, we're going to have to take away the 25. In order to do that, the opposite of multiplication is division. So we're going to divide each side by 25 liters. And that gives me 2.5 times 15 divided by 25 equals P2. And that is what you were going to plug in your calculator, 2.5 times 15 over 25. And that is going to give you 1.5 ATM. Moving on to question 19. In the lab, students perform a neutralization reaction between lithium hydroxide and hydrobromic acid. Our equation is right here. It says, what are the products formed in the neutralization reactions? When we talked about neutralization reactions, we went over the base equation for neutralization reactions. That was HX plus YOH yields YX plus H2O. Okay? And the H2O is in black because you're always going to have H2O at the end of a neutralization reaction. Okay? So in this case, the YOH, which is your base, is going to be your lithium hydroxide. And the HBr is going to be your acid. Okay? This is your acid. This is your base. So if we rewrite our equation in this order, we have HBr plus LiOH is going to yield blank plus H2O. Okay? In this case, it is X and Y. So we're looking for the X and Y in the two compounds that they give us. We're going to leave off the H and we're taking the Br, that's going to be our X. We're going to leave off the OH and we're going to take the Li, that is going to be our Y. So this is X, this is Y. We're going to switch those, so LiBr. And that is going to be the compound that we're going to use for our neutralization reaction. So in this case, there's only one option. Your answer is going to be B plus H2O. Okay, so question number 20 reads, which statement describes an Arrhenius acid? We know that our acids are always going to start with H. And our bases are OH. Okay, and this is a H plus ion. We have an O negative. So anything that has O negative, we can go ahead and cross out because we know that that has to do with bases and that's not what it's asking for. So A has OH negative and so does D. So we're going to go ahead and cross out both of those answers, okay? So we're left with two answers, a substance that produces an H plus ion when dissolved in water and a substance that accepts an H plus ion. So we're going to go ahead and cross out C because we know that our acids are always going to produce an H plus ion when dissolved in water. So our answer is going to be B. Question number 21 says, the unbalanced reaction shown represents the decay of uranium-238. What kind of particle must be emitted to balance this equation? Okay, so we know that uranium-238 is an isotope, and we know that this reaction is going to be a fission reaction because we have a larger atom that is splitting into one, and we'll find the second one, but two smaller atoms, okay? In order to balance this equation, 234 and whatever atom we're going to put right here have to add up to 238. So at the top, we have 238 minus 234. So the top has to be 4. And then we have 92 minus 90, and the bottom has to be 2. Okay, so we're looking for 4, 2. It says what kind of particle must be emitted to balance this equation. Okay, so your particles that are going to be emitted deal with your radiation. So our answers are alpha, beta, neutron, and positron. We can go ahead and cross out D because that is not a particle that we talked about being emitted. We only talked about alpha, beta, and then neutrons. Okay, so we're going to go ahead and go back to our formula sheet, and we're going to go to the side that has our constants and conversions, okay? Remember, your radiation particles are going to be underneath your constants and conversions. You have to remember when to use it. So it's talking about particles right here. It gives us our alpha particle, which is 4,2 helium, our beta particle, which is 0, -1 e, an electron, and then our neutron, 1 over 0 n, okay? So we already decided that our numbers have to be 4 over 2, our mass and our atomic number. If we look at our particles, the alpha particle is the only particle that has 4 over 2, which will solve this equation. So the answer is going to be A, alpha.